Okay, I'm going to talk to you a little bit about what we're doing here. So I'm going to go ahead and go to the simulation. And I know that you said you've done some of this, but I just want to make sure that you're okay with it all. And then if you have any questions, let me know. So for instance, here at the introduction, it's just showing you guys like what this does. So for instance, water, I filled out for you. It's a pH of 7. If I do the litmus paper, now I know it should be close to a 7, right? Because that's what this just told me it was a 7. So this should be close to a 7. And it is, so I'm just going to write orange and 7. It's kind of an orangey yellow, but it's orange. And then lastly, you're going to look at this, and there's a little bit of a light. But then when you go to strong acid, you can really see what that light does. Okay, now going back to water, I can look at my molecules and you can see that for every 2 acid particles, which is my H3O, I have 2 OHs, which is my base. Now if I look at the graph, it's 1 times 10 to the negative 7th and 1 times 10 to the negative 7th. That's where I'm getting those numbers from. So it's just going back and forth between these two views. Right? So now if I go to strong acid, I can do this. It's a bright light. I can dip my pH paper. I can do my pH. It's 2. Now the graph, though, I don't like the graph on this. I don't know what it is doing here. It is the acid is 1 times 10 to the negative 2nd, which is showing you that for your acid. Now your base would be 1 times 10 to the negative 12th, so it doesn't show that on here. Same for weak acid. It's showing me just my acid. It is not showing me my base. I guess, it's not showing me my base really. So it's just showing me the acid. My strong base is just showing me my base. I know it's still, my base should be 1 times 10 to the negative 12th. So I don't really like what they've done with this graph. So I told the other kids that not to worry too much about the graph, just write down what it tells you. I'm not going to be really looking at that too much. All right, so once we get done with doing the weak base, the strong base, all of that, we're going to go to my solution. Now, this right here is what I am comparing everything from. So I'm looking in my, let's go back to this worksheet here. This is what I'm comparing everything to. My pH is 4.5. Dip the pH meter in the liquid. What is the pH? Did that. Your concentration, make sure you know your concentration is at 0.01 right here. How many H3O molecules? You're counting them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'd write a 10 here. The litmus paper, same thing. We're just clicking on litmus paper, dropping it down, and what should it be? Now I know that it's going to be somewhere between 4 and 5. It's just kind of like, do you think it's closer to the 4? Do you think it's closer to the 5? That's up to you. So that's what I'm going to compare everything to. So then what I'm looking at is I'm going to look at what happens when I decrease or increase concentration. So anytime that I redo this, I'm going to restart. I'm always going to click this restart button. And I'm going to decrease my concentration. Now I don't care. You could go all the way to the bottom here. You could just go here in the middle. I don't care as long as you decreased it. And you're going to tell me what your new concentration is. So for instance, I would have 0.004. I'm going to do the pH meter. What is the pH? Now yours might be different. You may have done a different concentration. Now to find my H3Os, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of them. You can see as my concentration, look at this, as it goes, I lose more and more of them. 1, 2, 3, 4, 5, 6, 7. So it just depends on where your concentration's at. Okay? Now once you do this, now you're going to increase the concentration. So I'm going to, once again, I'm going to restart everything, and I'm going to increase. Now, it depends. Like, how much are you increasing? I could increase to 0.344, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I think, and I may have missed one, I don't know. But I've got 16 H3Os. The pH meter, you can dip in there real quick, all of that. Once again, it depends on the concentration you used. If you went here, like, you're going to have less, right? So it just depends on what you used. And then your litmus paper. Here is where I really want to make sure that I talk to you about claim evidence reasoning. We use it a lot in biology too, and I started trying to incorporate it into chemistry. So my claim is, what did this tell me? When I investigated and I decreased and increased the concentration, what did I find out? Well, I did this with them. There's a couple different things you could say. You could say, well, as I decreased concentration, something happened to my pH, or as I increased it, something happened to my pH, and what happened? I, though, looked at my H3O. There's no right or wrong when it comes to that. You could have talked about your pH, and that's fine. This is what I did. I said, looking at my original, and as the concentration increased, my H3O increased. Now, I could have said, as my concentration decreased, my H3O decreased. But I did not. I said, as concentration increases, my H3O, H3O also increases. My evidence, now for me, it went from a 10 to a 12, so that was my evidence. My evidence is like what happened. So my evidence was my H3O increased from 10 to 12 when I increased my concentration. Okay, that's my evidence. My evidence are the numbers. In biology, it's usually a chart, a graph, some study that's been done. That'll be my evidence. Now, the reason, this is the hardest part for kids, is the reason of, okay, I've got my claim and my evidence. The reason is the why. Why did it happen? Well, I could say the more acid I have, which is the increasing of concentration. Now, you don't have to write that. I'm just trying to explain to you. So the more acid I have, increasing the concentration, the more hydrogens there will be to make H3O. That's the reason. Right? So I'm going to get rid of this because everybody's going to be able to see this from here until eternity if I keep it there. So I'm going to erase that so you can pause this if you need to and write that down. But that is my claim, evidence, and reasoning. Now, this is your guys' first time with me doing this, so I will be a little bit lenient with it. If you're having trouble with the reasoning, let me know because I have had to help quite a few of them today. When I go to the next thing, though, it says make the following changes. Every time I do this, I'm going to reset back to my normal. And now it says change from a weak to a strong acid. So I make sure it's reset, and I'm just going to go weak to strong. And I'm going to answer all those questions and do the CER. Now, when I go on this page, change over to a weak base. So I'm going to reset everything, and then I'm going to go to a base, and it's on weak. So now I'm on a weak base. Every time that I make the following changes, I want to make sure that I reset it, and I'm doing what I'm supposed to, like make sure I'm on a base. So when you reset, make sure you realize that it sets you back automatically to an acid. All right? So that is how you kind of use this, and that's how you do CERs. Once again, let me know if you're having trouble with any of those CERs, and I will help you. It's all about the number of hydrogens. How much acid you have. The more acid you have, the more hydrogens. It works the same with bases, too. The more base you have, the more OHs you have. Right? It also works for strengths and weaknesses. The stronger the acid, the more it will break down. The more it breaks down, the more hydrogens you have to make H3O. So that's this was just a good kind of introduction back into things, and also being able to go over some of these concepts we did. We are going to be doing hands-on lab. I'm just going to not put a grade in for you. It's going to act like it's never even, like that was never a thing for you. So it's not going to hurt or help you, but just, I guess tomorrow, some of them are going to finish this up, and then we're going to do a hands-on lab with this stuff, and just don't worry about it, okay? All right, if you need anything at all from me, let me know, and I will see you next week, I guess. Bye.